Hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. So here also we are going to solve the large sample problems and solution using the discrete mathematics, the probability and hypothesis testing. So first of all, we will see what are the already we have discussed the problems involved in the large sample. Another problem we are going to discuss today. An online advertising team is running A to B is compared to the previous two copies for new product launch. For example, they have given the red control and blue control as 5000 and 4800 and mean clicks rate of 4.82 and 5.31. The standard deviation of CTR is 1.2.5 and 2.3. So here the large sample at the Z test is given and answer will be given data is nothing but n is equal to 5000 and the blue is nothing but 4800 and the mean CTR is 4.82 and 5.35. The standard deviation is 2.1 and 2.3. Here the alpha test is nothing but 5% level, and here also we have to test the null hypothesis and as well as the alternate hypothesis. If the null hypothesis means h naught equal to mu naught, whereas the alternate hypothesis h naught equal to mu is not equal to mu naught. So let us see that if there is a two mean means we have to compare the x1 minus x2, and whereas the root of x1 instead of x1 x2 we are writing as a blue minus a red, root of sb square by nb plus sb square by nr. So there is nothing but a two sample mean we are going to consider. So already the mean is 5.31 minus 4.82. The difference is 0.41, whereas the standard error we can represent it as 2.3 the whole square plus 4800 plus 2.1 the whole square 5000, and if we simplify we will get 0.044. Here the z value is nothing but if you substitute the 0.549 divided by 0.0446, that is will be equivalent to a 10.99. But here the alpha is 5%, but the right tail test, right tail left tail, right tail test means the value will be 1.641. The decision value is z greater than 1.645 means we will reject the null hypothesis and we can accept the alternate hypothesis. So what is mean by alternate hypothesis? The 5% significant means the strong evidence that the blue copy has a significantly higher CTR than the red control, and we can find the marketing team should roll on the blue and copy to the full audience while continuing to the monitor performance such as conversion rate and the cost per acquisition. Next we will see the another problem. We have taken a Facebook problem with the new feeding algorithm to increase the engagement of the customers, and the randomly assembled using for the two groups measured in average daily active, how many of them are active. For example, the old algorithm is used for the group and another one new algorithm is used for the another group. Here they have taken the sample of 3000 and 2700. Here the mean is 42.6 and 45.1 and the standard deviation is 15.4 and 16.5. Here they have taken the large sample with a significant effect of 5% and we have to complete the one tail test. Previously we have seen that a two tail test, but here we are going to analyze the one tail test. Here based on the performance of the problem we have distributed the n value as given as 3000 and 2700, whereas the mean 42.6 and 45.1, whereas the standard deviation is 15.4 and 16.4. So based on that application we have to same formula we have done previously. Two means x1 minus x2. Here we can represent it either by x1 by minus x2 or else xtc by xtc, and we apply this value we will get 2.5 divided by 0.420 that we got from the standard error. So and we applied the right tail test means the if it is a right tail test means 1.64. 1.64 if we compare with the 5.95 means it is greater value, so we will reject the null hypothesis and we accept the alternate hypothesis. So based on the alternate hypothesis it is an 5% significant level means we can conclude that the strong statistical evidence that new feed algorithm significantly increases daily active usage. So we will recommend the new algorithm based on that concept. Okay, so like that we have to proceed the all the problems in the two sample mean. So I think everyone understand the two sample mean based on the idea. So thank you students for watching this.